This problem is looking at graphing polynomial functions. So we're looking more specifically at graphing this cubic that we're given in this function. And we know it's a cubic because it's in descending order and our leading term has a degree of 3. It first asks us to find the zeros. We can do this a number of ways. We can use synthetic division or we can try grouping. So I'm going to try grouping with this one. So let me rewrite the function over here, and we're going to do the process of grouping. Now we can do that because we have 4 terms. So our first step of grouping is to group. We're going to say plus all of this. And then our second step is to factor out the GCF in each group. So what is in common in the first 2 terms? We have an x squared that's in common. And if we're going to take that x squared out or factor it out, we need to divide. So if we're putting an x squared in the front, we're going to divide by x squared on both of these. X cubed divided by x squared, subtract the exponent, So that's just going to give me x, plus the x squared over x squared will cancel. So that's 3. And again, this is a -4, so we're going to be really careful. Here, our GCF is going to be negative because the first term in this group is negative. So if the first term in the group is negative, the GCF is negative. And then what is in common with 4 and 12? It's 4. So we're going to divide both of these by -4. Once I do that, I get x, and the sign here changes to a +3. Now our new factored form is x plus 3. And x squared minus 4. We can see that this can factor even more because this is difference of squares. So this can factor into x plus 2 and x minus 2. This is our completely factored form. How to find the zeros? Well, once we have our factored form, we want to set each of these equal to 0 and solve. Oftentimes, if these are whole numbers, as is the case in this problem, you can just change the sign to figure out the zeros. But if that's confusing, you can actually go through the process of solving each of these linear equations. So I get -3 for the first one, I get -2 for the second, and I get 2 for the third. So our zeros are just these numbers that we get after we set each linear factor equal to 0. So we have a list, -3, -2, and 2. From the zeros, we can determine the x-intercepts. Our x-intercepts are going to be the zeros for the for the x value and 0 for the y value. So let me say that again. We have whatever we got in the zeros here, which in the first one is -3. That's your x value of your x-intercept. The y value of the x-intercept will always be 0. So our first x-intercept is -3, 0. Our next one is -2, 0. And our next one is 2, 0. So those are 3 points that we know exist on this graph. Now let's find the y-intercept. Well, the y-intercept is very simple. Again, if the x-intercept has 0 for y value, the y-intercept has 0 for x value. So if I take x and I plug it in to this function f of 0, I get 0 cubed plus 3 times 0 squared minus 4 times 0 minus 12. And I just am showing you this so you can kind of have some understanding of what happens here and why the answer is the way it is. But if I plug 0 in, 0 cubed is 0. 0 squared is 0 times 3 is still 0. 0 times 4 is 0. So I'm only getting the constant as my answer, my y value to my y-intercept. And it's going to be like that every time because you're plugging in 0. Everywhere there's an x is going to turn out to be 0. So you can use this rule if you would like from here on out. that the y-intercept is 0 for your x value and then whatever your constant is, which is negative 12 in this case. Now let's talk end behavior. End behavior is what's happening on the ends of the graph. Does it go to infinity? Does it go to negative infinity? What happens as x gets bigger and as x gets smaller? Because this is positive here in the leading term, and we have a cubic, which is odd, then positive tells my right side that it's going up. So the right side's going up to infinity. And because it's positive, my right side's going up, but because it's odd, my left side's doing the opposite. So positive controls the right side, odd or even is going to either do the opposite or the same. But since this is odd, we're going to do the opposite. So if this goes up, this side's going down. Okay, so what I want to do first before I determine some in-between points is I want to graph these. So I've got these 4 points and I know the end behavior at this point. So let's, I know you're not going to be able to see this, but you'll be able to see the graph. So let's graph these points. So I had negative 3, 0. I had negative 2, 0. And I had 2, 0. Then I also had the y-intercept negative 12. Now I realize this is not on the graph, but we're going to just estimate. It's around there. The other thing that I know is that this is a polynomial, so it's curvy. It's not a polygon, it's not line segment, so this is going to end up being a curvy graph when we're done. I also know the end behavior. I know that at this rightmost point, the end behavior is going up from there. So I'm not exactly sure how curvy it will be, but we do know it goes up. On the leftmost point, we know the end behavior goes down. Now, I'm not sure what happens here in between. So with any graph, you can pick any number for your x value, plug it in, and find a y value. So what I would like to do now is figure out what happens here at negative 2.5. Can that give us an idea of how far up this goes? What happens here at negative 1? And then what happens at 1. And this is not going to be perfect. We can't plot every single point, but we get a general idea of the shape. So what I want to do is just create an XY chart, and let's put those points on there. So we've got negative 2.5, negative 1, and 1. Now you could go and keep going and fill this out a lot more, but I'm not going to. We just want a general idea of what happens here. So negative 2.5 cubed plus 3 times negative 2.5 squared minus 4 times negative 2.5 minus 12. Let's see what that gives in the calculator. Okay, I get 1.125. Let's try negative 1. Negative 1 cubed plus 3 times negative 1 squared minus 4 times negative 1 minus 12. So I'm just plugging it into the function. Let's see what we get out here. The ones are pretty easy. You can almost, you could do this in your head probably. Okay, I got negative 6. And let's just try 1. So we have 1 cubed plus 3 times 1 squared minus 4 times 1 minus 12. So that's just going to be 1 plus 3 minus 4 minus 12, which is negative 12. Okay. Now, there's a couple things I want to note here. We have negative 2.5. So right here, it's going up just a little bit. We're talking barely above that line. Okay? So we can kind of fill out that. And then negative 1 is going down to negative 6. That fits in. That makes sense. So we can fill out that part. But I want to make a note right here. So 1, negative 12. Notice that's the same value as, you can't see that, here we go. Same value as the y-intercept. I don't want you, I mean, this is not going straight across. So because this is curvy, we just have to assume that this is going to go down a little bit more. Now we could certainly plug in 0.5 and get a more accurate measurement there or point there, but we just want to assume that it just keeps going down just a little bit more and goes back up. So that's how that works. It doesn't go straight across. It's not going to. It's not a line. Okay? So this is just a way that we can approximate and get a general sketch of a function that's a cubic. And again, remember we found our original zeros by using grouping.